A NASA spacecraft is set to make history today, getting closer to the Sun than any other human-made object.
Now studies say that our Sun has a long-lost twin, that once upon a time, it had a stellar companion too.
What if our Sun wasn't an only child? What if, far beyond the planets we know, there lurked a shadowy twin, an unseen companion silently orbiting through the darkness, waiting? A twin that might have been responsible for the death of the dinosaurs. A twin that could be the trigger for mass extinctions on Earth, over and over again. They call it Nemesis, the Sun's possible, long-lost partner in a deadly cosmic dance. It sounds like science fiction, but for decades, astronomers have been asking, could the Sun have a dark companion, and could it kill us? The story begins not with a telescope, but with fossils. In dusty museum basements and desert dig sites, paleontologists of the late 20th century began piecing together an unsettling puzzle. It wasn't just that Earth had suffered mass extinctions. That was old news. It was that these extinctions seemed to happen regularly, every 26 million years or so, like cosmic clockwork. Life on Earth got catastrophically rebooted. Dinosaurs? Gone. Trilobites? Obliterated. Coral reefs that had thrived for millions of years? Wiped out in a geological blink. Something, or someone, was pressing the reset button on evolution. The usual suspects were trotted out. Climate shifts, supervolcanoes, gamma-ray bursts, rogue asteroids. All plausible, but none explain the timing, the precision, the eerie rhythm in the chaos. The fossil record wasn't just telling stories of destruction, it was keeping time, a metronome buried in stone. That's when two researchers, David Raup and Jack Sepkoski, proposed a theory so wild it bordered on science fiction. What if our Sun wasn't alone? What if it had a hidden partner, a dim, distant star that lurked on the edge of the solar system? And what if, on its long elliptical orbit, this unseen twin periodically disturbed the Oort Cloud, sending a blizzard of icy death spiraling toward Earth? They called it the Nemesis hypothesis after the Greek goddess who punishes hubris. Fitting. If true, this shadowy star was more than just a curiosity. It was a cosmic executioner, and it might still be out there, biding its time. Because if extinction comes on a schedule, then we might just be overdue. Birth of a Nemesis theory. The year was 1984. Raup and Sepkoski's paper didn't just raise eyebrows. It sent shockwaves through the scientific world. Extinctions on a timer. That was provocative enough, but the implication that some external celestial force might be pulling the strings? That was revolutionary. Enter three astronomers, Richard Muller, Pete Hutt, and Mark Davis. They took the core idea and ran with it, straight into deep space. If extinction had a rhythm, there had to be a drummer. They proposed that our Sun wasn't the solo act we'd always believed it to be. It had company. They named this companion Nemesis, a nod to the ancient Greek goddess who delivers divine retribution. Apt, considering her role in periodically triggering planetary-scale death. Nemesis, they theorized, wasn't bright or bold. It was small, cold, practically invisible. A red dwarf, or perhaps even fainter, a brown dwarf, lurking in the outermost edge of the solar system, up to 1.5 light-years away. That's 30,000 times farther from the Sun than Earth. Beyond Pluto, beyond the Kuiper Belt, out in the frozen dark where the Oort Cloud begins, a spherical sea of icy debris. According to their calculations, Nemesis followed a long, elongated orbit, taking roughly 26 million years to complete a full lap. And each time it neared the Oort Cloud, its gravitational pull would send a cascade of comets inward. Some would miss, some wouldn't. Suddenly, extinction wasn't random anymore. It was a scheduled consequence of orbital mechanics. The theory had everything: cosmic mystery, prehistoric tragedy, and an unseen agent of doom. It was irresistible, both to scientists itching to solve a puzzle and to the public, eager for a villain lurking in the void. And just like that, the hunt for the sun's dark twin began. How Nemesis would work. To understand Nemesis, you have to wrap your head around the Oort Cloud and let go of any ideas of neat planetary rings or tidy belts. The Oort Cloud isn't a disk, it's a shell, a vast spherical swarm of icy leftovers from the birth of the solar system. Trillions of frozen bodies, some no bigger than pebbles, others miles wide, drifting silently in the dark. It stretches nearly halfway to Alpha Centauri. If the solar system were a city, the Oort Cloud would be the suburbs, 3 states over. Most of the time, it's quiet, still, undisturbed. But Nemesis would change that. Step 1, approach. Roughly every 26 million years, Nemesis creeps close enough to the inner edge of the Oort Cloud for its gravity to start tugging at the residents. Just a whisper of force, but in space, even whispers echo loudly over time. Nemesis's gravitational pull subtly shifts the orbits of thousands, maybe millions of comets. Most end up harmlessly deflected, but some don't. The unlucky few are slingshotted inward, toward the heart of the solar system. Some become the glowing comets we see in the night sky. Others turn deadly, traveling at tens of thousands of miles per hour. They become planetary wrecking balls. If one crosses Earth's path, game over. Nemesis wouldn't need to touch Earth to wreak havoc. All it has to do is shake the hive. The Oort Cloud becomes a cosmic shotgun, and we're right in the line of fire. One invisible star, trillions of frozen bullets, and every few million years, it pulls the trigger. Key takeaway number 1. Binary stars are the rule, not the exception. If the whole idea of Nemesis sounds like something ripped from science fiction, a hidden companion star lurking in the shadows, sending death from afar, then here's something that might surprise you. It's the norm. In our galaxy, most stars aren't loners. They're part of a duo, or a trio, or sometimes even more. Astronomers estimate that over half of all sun-like stars exist in binary or multiple star systems. That includes stars that form together and now orbit one another in a predictable gravitational ballet. Some pairs are majestic and bright, twin suns circling each other in plain sight. Others are mismatched, a large glowing primary star partnered with a dim, cool red dwarf. Or in some cases, something even harder to spot, a brown dwarf, barely glowing at all. These faint companions are almost invisible without specialized equipment, yet they're still gravitationally bound. Even Alpha Centauri, our next-door neighbor in cosmic terms, is a triple system, not a solo act. So if our own sun were born with a partner billions of years ago, it wouldn't be strange, it would be expected. The real oddity might be that we haven't found one. Could Nemesis have once been part of a binary system with the sun, only to drift apart on a massive elliptical orbit? Or maybe it's still out there, just far enough and faint enough to avoid detection. The big question isn't could the sun have a twin? It's where did it go? And what has it done? The extinction connection. The Nemesis hypothesis didn't just make headlines because it was dramatic. It gained traction because it fit. It seemed to line up with something very real. The fossil record. Consider the most famous extinction of all, the End Cretaceous event, 66 million years ago. That's when the dinosaurs disappeared. Along with nearly 75% of all species on Earth, the leading theory? A massive asteroid slammed into what's now the Yucatan Peninsula, carving out the Chicxulub crater and kicking off a global disaster. Was that asteroid just a cosmic accident? Or was it Nemesis at work, lobbing icy projectiles at Earth on schedule? Raup and Sepkoski's extinction timeline didn't stop there. They pointed to other mass die-offs that seemed to follow a similar rhythm. The Permian Triassic extinction, the so-called Great Dying, and the Triassic-Jurassic extinction also matched the 26 million year pattern. Each one wiped out ecosystems, reset evolutionary progress, and opened the door to new life, only for the cycle to repeat. Nemesis, if real, provided a clean, terrifying explanation. A predictable cosmic trigger, not chaotic randomness. But not everyone was comforted by the elegance of the theory. Because if Nemesis exists, then mass extinction isn't just part of Earth's unpredictable history. It's part of its schedule. And here's the unsettling part. According to the pattern, we might be next. Key takeaway number 2. Our solar system is not a safe neighborhood. It's easy to think of the solar system as a well-behaved classroom. Planets spinning neatly in orbit, moons tagging along, everything running like celestial clockwork. Orderly, predictable, safe. But that's an illusion. In reality, we live in the middle of a cosmic shooting gallery. All around us, comets, asteroids, and rogue debris are flying through space at unimaginable speeds. Most are harmless. They pass by without incident. Some burn up in our atmosphere, but every so often, one doesn't miss. And that's where the Oort Cloud becomes more than just a poetic idea. It's a stockpile of potential disaster, a vast, icy minefield surrounding our solar system. Beautiful? Yes, but it's also a loaded gun pointed inward. All it takes is the right trigger. A passing star brushing just a little too close, a gravitational ripple from a giant molecular cloud, or in the case of the Nemesis hypothesis, a hidden companion star making its regular deadly visit. Any of these can disturb the balance, sending a swarm of comets tumbling toward the inner planets toward us. Nemesis may or may not exist, but the larger truth is unavoidable. It's not the only threat. Whether or not we ever find Nemesis, the takeaway is clear. Earth's continued survival has always been a matter of luck, and space does not care. The science behind Nemesis. So what is Nemesis supposed to be? If it exists, astronomers believe it would fall into one of 2 categories. A red dwarf, the most common type of star in the galaxy. Small, cool, and incredibly dim. Red dwarfs can burn for trillions of years, but their faint glow makes them notoriously hard to detect. Or a brown dwarf, the so-called failed stars. These objects are too big to be planets, but not quite big enough to ignite nuclear fission in their cores. They give off only a faint trace of heat, mostly in the infrared spectrum, making them nearly invisible in normal light. So why haven't we seen it? Simple. We couldn't. Not until recently. For most of the 20th century, our telescopes weren't powerful or sensitive enough to detect something that faint, especially if it was sitting halfway to the next star system. Nemesis, if it exists, would be on a long, highly elliptical orbit, drifting far out into space for most of its 26 million year cycle, only briefly approaching close enough to disturb the Oort Cloud. For most of its journey, it would be buried in darkness, too far and too dim for traditional telescopes. But then came infrared sky surveys. And here's the twist. We've looked. With missions like WISE, NASA's Wide Field Infrared Survey Explorer, we scan the sky for hidden stars and cold objects. The result? No sign of Nemesis. At least, not yet. Evidence and counter-arguments. In 2014, NASA's WISE mission, a powerful infrared telescope orbiting Earth, completed a comprehensive survey of the entire sky. Its goal? To detect faint, cold objects that might have escaped earlier observations. If Nemesis wasn't out there, a Jupiter-sized or larger object within 10,000 astronomical units, WISE should have seen it. It didn't. That distance, by the way, is about 250 times farther than Pluto, exactly the sort of range Nemesis was theorized to occupy. The WISE data was a serious blow to the hypothesis. But the skepticism didn't stop there. The periodic extinction pattern? Some paleontologists and statisticians now argue that it's less compelling than it once seemed. Maybe those 26 million year intervals were just a fluke, a coincidence produced by imperfect fossil records and human pattern-seeking tendencies. And even if we do occasionally get pelted by comet showers, that doesn't mean a hidden star is responsible. Some astronomers suggest simpler explanations, like random stellar flybys, nearby stars occasionally passing close enough to nudge the Oort Cloud. It's rare, but it happens. and it doesn't require a permanent resident like Nemesis lurking in the dark. In short, the case for Nemesis has weakened considerably over the years, but it hasn't vanished, because in science, the absence of evidence is not evidence of absence. The sky is vast, the data incomplete, and the cosmos still holds secrets. The question isn't settled, it's just paused. Key takeaway number 3. Even if Nemesis isn't real, the search matters. The hunt for Nemesis was never just about finding one rogue star. It was, and still is, a window into something much bigger. Our solar system's origins, its structure, and its long, sometimes violent relationship with deep space. If Nemesis existed, it would rewrite major chapters of astronomy. It would mean our sun likely formed in a binary pair, a revelation that would reshape our understanding of how stars are born and how common solar twins are. It would also shed light on the frequency and mechanics of mass extinction, not just as biological events, but as cosmic consequences. But even if Nemesis turns out to be nothing more than a clever hypothesis, the search itself has been invaluable. In trying to find it, astronomers built better tools. Missions like WISE gave us detailed infrared maps of the entire sky, leading to the discovery of dozens of nearby brown dwarfs. Strange, silent neighbors we never knew existed. The search also pushed forward our understanding of comet behavior, Oort Cloud dynamics, and how external forces can shape the solar system over eons. So yes, maybe Nemesis isn't out there, but the process of looking sharpened our vision, expanded our maps, and deepened our questions. Sometimes, the chase is just as important as the capture, because in science, every dead end still leads somewhere. The future of the hunt. The hunt for Nemesis isn't over, not by a long shot. It's about to enter a new era. With next-generation telescopes coming online, like the Vera C. Rubin Observatory in Chile, our ability to scan the heavens is reaching an unprecedented level. Rubin's Legacy Survey of Space and Time, LSST, will photograph the entire sky every few nights, capturing even the faintest moving objects against the backdrop of stars. If Nemesis is still lurking out there, even as a dim red dwarf or a cold brown dwarf, Rubin has a real shot at spotting it. And if it finds nothing, that's still progress, because along the way, we'll uncover more about the solar system's outer frontier than ever before. Unknown asteroids, new dwarf planets, wandering interstellar objects, and maybe even clues about the true shape of the Oort Cloud. The search for Nemesis has always been about more than one mystery. It's about confronting the unknown and building the tools to do it better each time. So the question remains, as haunting now as it was 4 decades ago. Is the sun alone? The answer is out there, and the next decade might finally bring it into view. The Nemesis theory may be fading, but the mystery remains. If the sun has a twin, it's been hiding for billions of years, and it might hold the key to understanding life, death, and extinction on Earth. Real or not, it's a reminder that the universe isn't static. It's alive with motion, change, and sometimes danger. So what do you think? Is Nemesis science or science fiction? Subscribe for more journeys to the edge of what we know, and let's keep looking up. Stay blessed and stay curious.